The comparative advantage goes to the economic agent with the lower opportunity costs for the production of a good or service. In this example, we have Blue Tribe and the Orange Tribe. We can see their production possibilities frontiers on the graph on the left, and on the right, I have their maximum possibilities summarized. In the previous video, we noted that Blue Tribe has an absolute advantage in the production of both fish and berries. So why would they ever want to trade with Orange Tribe? The trade will only happen if it is mutually beneficial, and it will only be beneficial to Blue Tribe if it somehow lets them push beyond their PPF to something unattainable on their own. The key to comparative advantage is the opportunity cost of producing something. I've reformatted our information about the Blue Tribe and the Orange Tribe into this production chart. We can note right away that since they have the larger capacity for producing fish, Blue Tribe has the absolute advantage in fish. And since Blue Tribe also has the larger capacity for producing berries, Blue Tribe has the absolute advantage in berries. But let's say that the people on Blue Tribe want another fish. However much fish they had, they want one more. Well, presuming that they're operating efficiently on their PPF, it means they will have to give up some berries because they have to shift some of their time and effort from berries to fish. So we can measure the cost of that fish in terms of the berries given up. That is what we call the opportunity cost. If you want to calculate the opportunity cost of X, you take your quantity of Y given up and divide it by the quantity of X gained. Let's apply that to our numbers on the chart by creating a new chart of opportunity costs. The Blue Tribe faces a trade-off. If they go all out on fish, they will produce 200 fish and 0 berries. Alternatively, if they go all in on berries, they will produce 210 berries and 0 fish. We can use those numbers to calculate the opportunity cost. The opportunity cost of a fish takes the 210 berries we give up and divides it by the 200 fish that we get. Notice that we want the opportunity cost of a fish, and so we divide by the number of fish. That gives us 1.05 berries per fish we gain. That is the opportunity cost of one fish, 1.05 berries. Let's do the same calculation, but for Orange Tribe. For them, we take the 165 berries we give up and divide by the 170 fish that we gain to get an opportunity cost of a fish for Orange Tribe of around 0.97. I rounded a bit. Now let's do the calculation for berries. For Blue Tribe, we take the 200 fish we give up and divide by the 210 berries we gain, giving us an opportunity cost for a berry of around 0.95. For Orange Tribe, it's 170 divided by 165, which is around 1.03. The comparative advantage goes to the tribe with the lower opportunity cost. For fish, this is Orange Tribe. 0.97 is less than 1.05. For berries, this is Blue Tribe. 0.95 is less than 1.03. So, why does this matter? Well, if Blue Tribe wants another fish, they could produce it themselves at the cost of 1.05 berries. Alternatively, let's say they go to Orange Tribe and offer one set of berries for one fish. Giving up only one set of berries instead of 1.05 for a fish is savings for the Blue Tribe. So if Orange Tribe accepts, they'll end up better off. But is it beneficial for Orange Tribe? Well, They would have to shift production from berries to fish in order to catch that extra fish for Blue Tribe. To get one more fish, they give up 0.97 berries, which is less than one. So Orange Tribe makes a little profit in berries and doesn't lose any fish of their own. The trade is mutually beneficial for both tribes. We can think about the benefits of trade using the PPF. Let's say each tribe has picked a point on their PPF. Since Orange Tribe has the comparative advantage in fish and Blue Tribe has it in berries, they will each want to shift their production in that direction. Then they can trade with each other one for one, or according to whatever agreement they come to, which allows them to push beyond their respective PPFs to previously unattainable outcomes. And the reason they can do this is because they're able to take advantage of each other's lower opportunity costs. Let's look at another example, which might clarify this even more. Let's say we have two bakers, Sandra and Rob. To bake a cake, they have to produce some batter and some frosting. The table shows some of the possibilities each of them have in terms of baking cakes each day. Sandra is very good at making batter, but slow when it comes to frosting. Rob is the opposite. He's good at making frosting, but not batter. We can chart out their production possibilities frontiers here, just like we did when we first looked at the PPF. To get one cake, you need one batter and one frosting. So this 45-degree dotted line shows where we need to fall to get full cakes without any leftover batter or frosting. If Rob and Sandra work separately, then they each end up producing 13.33 cakes per day. Sandra has to devote most of her time to frosting because it takes her longer to produce frosting. Rob has to devote most of his time to batter because it takes him longer to get one cake's worth of batter. Total, we have 26.66 cakes. But what if they traded? The opportunity cost of batter for Sandra is 20 frosting divided by 40 batters, which is 0.5. For Rob, the opportunity cost of batter is 40 frosting divided by 20 batter, which is 2. Since 0.5 is less than 2, Sandra has the comparative advantage in batter. And likewise, Rob has the comparative advantage in frosting. If they each specialize in what they're good at and trade with each other one for one, they're able to produce 20 cakes each. Sandra makes 40 batter, Rob makes 40 frostings. They each give each other half, and so both end up with 20 whole cakes. And we all end up with 40 cakes instead of 26.66. It's mutually beneficial. Indeed, one mistake many small business owners make is trying to do everything themselves instead of contracting with other businesses to take care of things they are better at doing. Let's do one more example just to make sure we've got it. Here I have two countries, A and B, and they're each going to produce lemons and/or limes. Country A maxes out at 120 lemons, or instead, they could max out at 135 limes. Country B maxes out at 100 lemons, or 125 limes. So who has the absolute advantage in lemons? That would be country A, who can produce 120 lemons to B's 100. And who has the absolute advantage in limes? Again, this is country A, where 135 is more than 125. So is there any opportunity for mutually beneficial trade? Certainly. To see what it is, we need to calculate their opportunity costs. In country A, the opportunity cost of a lemon is 135 limes divided by 120 lemons. You always divide by the thing you're getting the opportunity cost for. What this means is that in order to get those 120 lemons, country A is giving up the chance to produce 135 limes. That is 1.125 limes given up per lemon gained. And the value of knowing this is that we know if country A decided they want one more lemon, they would need to forego 1.125 limes because those resources will be redirected. In country B, the opportunity cost of a lemon is 125 limes divided by 100 lemons. If country B wants one more lemon, they have to give up 1.25 limes. The opportunity cost of a lime in country A is calculated just the opposite way, 120 lemons divided by 135 limes, which rounds to about 0.89 lemons per lime. For country B, it's 100 lemons divided by 125 limes, or 0.8 lemons per lime. With these calculations, we can find the country with the comparative advantage in each thing. Since 1.125 is less than 1.25, country A has the comparative advantage in lemons. Since 0.8 is less than 0.89, country B has the comparative advantage in limes. If you haven't noticed yet, there's a shortcut you can take when determining who has a comparative advantage. In this example, country A has an absolute advantage in both lemons and limes. That's possible with absolute advantage. One country can have it in both goods, just one of them, or none of them. But when it comes to comparative advantage, the two countries will always split it. So once we know that country A has the comparative advantage in lemons, we can immediately conclude that country B has the comparative advantage in limes. The math will always work out that way.